previous classes I discussed about work and work power. So now in this class I am going to discuss about energy. So energy means a capacity of a body for doing work. So energy, a capacity of a body for doing work is called energy. The SI unit of the energy is joule. Energy is a scalar quantity. Energy is a scalar quantity, and the dimensional formula for energy is E dimension energy E equals m power 1 L square T power minus 2. So the SI unit of energy is joule. The energy is a scalar quantity. The dimensional formula for energy E equals m power 1 L square T power minus 2. And various types of energies are there. So first one, mechanical energy, heat energy, sound energy, light energy, and wind energy, solar energy, and etc. So now we are going to discuss about mechanical energy. Mechanical energy means a body or the energy possessed by a body due to its position or motion. A energy possessed by the body due to its position or motion. And there are two types of mechanical energy. First one, kinetic energy. And kinetic energy is denoted by symbol Ke, and we should not use any other symbols. Second one, potential energy, and denoted by symbol Pe. So mechanical energy are two types. One is kinetic energy, second one potential energy. So kinetic energy. Kinetic energy means the energy possessed by the body due to its motion. So define kinetic energy means the energy possessed by a body due to its motion. So example for kinetic energy means a bullet fired from a gun. Second one, a man standing in a moving train or moving vehicle. So next one, potential energy. The energy possessed by a body due to its position. So define potential energy means the energy possessed by a body due to its position. Example for potential energy is a water behind the dam, and second example, a car top of the hill. So here the kinetic energy means the energy possessed by a body due to its motion. So potential energy means the energy possessed by a body due to its position. For the 3 marks question will arise like derive the expression marks question will be derive a expression for kinetic energy Ke equals of mv square. Okay, let consider it is a body or object. Let consider it is body or object. A body of the mass m. Without applying any energy, the body at rest. So initial velocity of the body u equals 0. When force applied to the body, when force applied to the body move from one position to another position. So the final velocity v. S is a distance or displacement. Let the equation of linear motion v square equals u square plus 2as. The equation of linear motion v square equals u square plus 2as, where v is a final velocity, u is a initial velocity, a is a acceleration, s is a displacement. So consider when u equals 0. So u equals 0. So v square equals u 0 plus 2as. So this equation can be written as v square equals 2as. Now this can be written as a equals v square by 2s. So this equation can be written as a equals v square by 2s, where a is a acceleration, we know that work done equals force into displacement. So W equals work done, W equals force F into displacement S. But force equals mass into acceleration. So F equals mass into acceleration A. Now W equals, where F can be written as m into A. So m into A into displacement S. So W equals m, where A is written as acceleration, A equals v square by 2s. So v square by 2s into s. So in this equation, s and s get cancels. So remaining W equals mv square by 2. So s get cancels. So remaining W equals mv square by 2. So now W equals, so this can be written as of 1 by 2 mv square. So mv square. So W equals of mv square. So therefore, work done appears as kinetic energy Ke equals half mv square. So this can written as, so work done appears as kinetic energy Ke equals half mv square. So now I will repeat once again. Derive an expression for kinetic energy Ke equals half mv square. So let take equation of linear motion v square equals u square plus 2as, where u initial velocity u equals 0. So v square equals 2as. So this equation can written as a equals v square by 2s, where a is a acceleration. We know that work done W equals force F into displacement S, but F equals force equals mass into acceleration. So W equals m into ma into S. So W equals m, where acceleration A is v square by 2s. So v square by 2s into s. So s get cancels, remaining W equals mv square by 2. So this can written as W equals half mv square. So work done appears as kinetic energy means Ke equals half mv square. Now another question, obtain the relationship or relation between kinetic energy and linear momentum. So another question, obtain the relation between kinetic energy and linear momentum. We know that kinetic energy Ke equals half mv square. So kinetic energy equals half mv square. Now multiply and divide by m. Now we have to multiply and divide by m. So Ke equals half mv square multiply by m. So into m divide by m. So divide by m. So now Ke, kinetic energy Ke equals half m into m square, m square into v square by m. So m into m square, v square by m. So Ke equals Ke equals m square v square by 2 into m 2m. So Ke equals m square v square by 2 into m 2m. So Ke, so now linear momentum P equals mass into velocity. So P equals m into v. So Ke equals m square v square can written as p square, because linear momentum P equals m into v, mass into velocity. So written as p square by 2m by 2m. So therefore this p square can written as p equals square root. So p square can written as p equals square root 2m into Ke. So this shows that the relationship between linear momentum and kinetic energy. So I will repeat once again. So obtain the relationship between kinetic energy and linear momentum. We know that kinetic energy is Ke equals of mv square. For this we have to multiply and divide by m. Then Ke equals of mv square multiplied by m, so into m, divide by m, so m by m. So Ke equals of m into m square v square by m. So Ke m square v square by 2 into m 2m. But the linear momentum P equals mass into velocity, so m into v. So Ke equals m square v square can written as p square by 2m. So therefore this p square can written as p equals square root 2m into Ke. So this equation shows the relationship between kinetic energy and linear momentum.